On 14, the trick to this question is that you have to read it slowly and read it carefully and slowly. So as you go through this, you'll notice you've got brothers and sisters, or two sisters trying to buy a bike. I don't know if you guys, well, you might know most of you guys have brothers and sisters. Do you think it's a smart idea for the two of you to share one bike? No, it's not. Trust me, as a parent, you don't want your children to share anything. It's awful. I'm joking. No, I'm not. So one person has $73 plus something is going to equal a bike. Thank you. It'll equal a bike. Thank you. And the other girl has $65 plus some other amount of money to equal, I'm not even going to bother doing this, I'm going to cheat. Another bike. We have the technology, let's use it. So if they put their money together that they have right now, they can get a bike. How much money is a bike? Done. What were you guys freaking out about this problem? I told you. Remember, if they combine their money, they will have just enough to buy the bike. Well, I'm just rephrase this. They need $73 more. They need $65 more. Well, if this one has $75, they need $75, the other one needs $65, that means the other person has that exact amount of money to add up to equal what's left over. So all you do is add the money together. Boom, you bought a bike. Isn't that just the dumbest question?
My head took me on the worst. I was like, well, they have no money, or they already have money. And
I know. I know. So, other than that, question, was there anything else you guys were screwing up that you're just driving you absolutely crazy, forgot how to do back in the chapter 1? Yeah, you forgot how to math. Is there anything else in here that you forgot how to math? Were you okay with the inequalities and the absolute values? Did you?
Let's see.
Let me show you how to do the inequality one's not that bad. It's when you're dealing with absolute value, because it's probably been a while since you guys have seen the absolute value problem. You guys did 22, correct? Yeah. So if I'm looking at 22, whenever you're solving an an absolute value equation, you're solving for two different sets of values. You solve it for exactly the same, and then since this is an equal sign, you solve it for the opposite of it. You have to negate it. If it was the inequality one, you'd solve for the same, it would have to equal 7. It would be greater than 7, or it would have been less than or equal to 7. That's how you would change and flip them around. But since we're dealing with just this one, your two equations will be 4 minus x is 2 minus 3x, and the other one would be -1 times the quantity 4 minus x equals 2 minus 3x. And those are the two equations you solve for. They're really fast ones. I hope I don't have to solve both, right?
Yeah.
Sure. Okay. So that's how those ones work. Other than that, I don't think there was a lot of craziness in one. Okay. So we'll just add to this with the 2 stuff today. So let's talk about chapter 2, gentlemen. Chapter 2 stuff. Chapter 2 stuff starts getting back into slopes, write equations of lines, parallels, perpendiculars, all that kind of fun stuff. So you have to remember what all of that means and how you work with all of them. It also introduces you guys to a couple of terms, domain and range. Domain and range. You probably dealt with them a long time ago when you guys first started talking about what's called function notation, whether or not something is a function. You might not have spent a ton of time on it, but do you remember what domain and range stood for? What is it? Right, it's X and Y. Domain and range, domain is all possible. What do you think, X or Y? X. The reason why we know it's going to be X because what comes first in the alphabet? Domain or range? What comes first in the alphabet, X or Y? So you'd have to go W, X. And this would be all possible. So all possible Y values. Domains and ranges allow us to determine whether or not a specific equation or a graph or a relation or something like that can be what's called a function. Functions, you guys have worked with. You've seen this. F of x equals x minus 3. What is f of 2? You've done that before. What do you do when you see f of 2? Exactly. Just replace the x with the 2, and you get 2 minus 3, which is negative 1, which means that the domain value of 2 generates a range value of negative 1. It's just basically plug and chug, if you will. Function notation, function values, function substitutions is a huge thing on ACTs, SAT style tests. The reason they do that a lot is because it's real quick to tell whether or not you know how to read, believe it or not, in a math class. For example, if you have f of x equals what I have here, x minus 3, and a g of x is x squared plus 1. You might see something like this. What is g of 2? What is f of g of negative 4? G of negative 2 means which equation are you working with? I'm sorry, g of 2, excuse me. It means you're working with the g equation because the letter is g. So all you're doing is substituting into the g equation, 2 squared plus 1, and you get 5. Okay? F of g of negative 4 means what do you do? Correct. Don't F anything. That was funny. You're right. It's order of operations. It's function notation. It works the exact same way as order of operations. Work on the inside innermost parentheses and build yourself out. We do a ton of this kind of stuff later on. We do a ton of it. And there's a little bit of it now, but later on, function notation, we do a lot of it with exponents and exponential values and things like that. 15 minutes apparently. On your calculators, do me a favor real quick. Take them out, and I want you to type in negative 4 squared. Did somebody in here still need a color one? That's right, Lori needs one. All right, I'll be able to switch it out with you, Lori, because I got B ditch dust.
Ditch dust?
She's got a bunch of other on her, so she doesn't want to do that. What do you want? I guess. I did. Did we name the fish yet?
No.
It's Billy, isn't it? It's Billy the bass?
This part of my head is my shirt.
I have one of those.
Well, think of something better then. Bartholomew. Yes, sir.
That's gonna be the kind of calculator that's gonna make my hand.
Oh, you need one too. All right, so I still need one more for you, Eddie. You and Lori need one, okay? All right, so real quick in your calculator, this is an important thing that you guys will regularly mess up. Hey, what is negative 4 squared?
16.
Why did the calculator say negative 16? Right. What's happening is that it's not in parentheses. What happens with these calculators is that they do it very literally. What they're doing here is taking the opposite of 4 squared. The opposite of 4 squared is negative 16, but you have to throw parentheses to group it. It happens all the time. Be careful, anytime you're squaring something that's a negative value, make sure you throw in parentheses, okay? It's a super common mistake. So, and like you were saying, is that we take the 4 squared, adds 1 to it, we get 17, then we just substitute 17 minus 3, and you get 17 minus 3, 14, okay. I just thought it was crazy or something. So, domain and range, remember, it helps us to determine functions. Do you guys remember the good old-fashioned vertical line test?
Nope. I didn't think so.
What is the vertical line test? The pencil test. Very good. What happens here is that we're going to be looking at a whole bunch of different graphs eventually. And so on. Yes, these are all different graphs. Linear. Does this look like it's a function? Again, what we're doing here is we're taking our vertical line, our pencil, if you will. Does this only touch one spot of the graph the entire time?
Yes.
That's a function. What about this one?
No.
Not a function.
No.
Yes.
Yeah, I just drew the axes to kind of show what it was. This is a cosine curve. What about this?
Yes.
Yeah. Do you know what graph that is? A V? What kind of equations give you a V for a graph? Absolute value.
Absolute value.
Very good. Absolute value graphs are all V's. They can be vertical, going upward, or they can be going downward. Just depends on the A value. And we'll talk all about that probably tomorrow. Okay. So we have that part in here. Change this page. It's out of page range. Function notation, this, that one. Slopes. How do you find slope?
Rise over run.
Rise over run, very good. Slope. Why do they use the letter M?
Measure.
No. Do you know why they use the letter M? Pretty much, because what's A, B, and C used for?
Alpha.
Pythagorean theorem, A squared, B squared, C squared. D is with diameter, distance formula. E, exponential. F, G, and H are all used for function notation. You see that all the time, like G of X, like I just did here, F of X, G of X. They use those for function. H is also used for height. J, oh, I forgot I. You know what I's for? Imaginary numbers. I'm thinking about it right now. J and K, there's what we call joint variation and constant variation. Constant variation, you guys probably studied before in Algebra 1. It actually is the precursor for slopes. I'll get you in 1 second. And then, I know you already looked up. And then L is width, lines, length, and they wound up on the letter M. I know I'm lying. You could have at least let me have my moment. I may or may not be telling the truth.
He's not. Don't trust him. He tried to
About,
us last
I
year.
would suggest, this is probably a fair assumption, about 85% of the things I say are true.
Yeah, he did it to us last year.
I'm sure he's did like.
Yeah, bless you. We had someone Google it earlier, and I believe they said the letter M, it might have come from monter, from the French word to climb, but there's really no correlation as to why the letter M. Bless you.
Someone else says like the same called modulus.
Yes, the modulus of the rate of change.
We all need to until
That's what I do. So anyway, slope. Rise over run. Change in Y. Change in X. You guys have all seen it with the delta symbol, right? The triangle? I would imagine.
Sure.
That's what that stands for. The delta symbol is a Greek letter. It stands for change in math. I'm not BSing this one. This is true. Maybe. Change in Y values, change in X values. It's very straightforward. I know you guys have all done this. This is not a big deal. It's not an issue at all. Sir?
I just searched on Yahoo and it says that also M is like in the middle of ABC and XYZ. I mean, what Y is Z?
I give you that one.
It's in the middle.
It's in the middle. When you write equations of lines that are parallel, when you write the equations of lines that are perpendicular, how do you know if something is parallel, if lines are parallel? Same slopes. You guys have all seen this, right? Parallel? Parallel lines have same slope. Perpendicular lines have what? Opposite reciprocals. Change the sign, flip the fraction. Opposite reciprocals. Those of you guys that had me in geometry, I'm sorry you got me again, but you remember when we did the equations of lines that are parallel, equations of lines that are perpendicular, I always went long form on that, and I forced them to kind of write out a couple extra steps. The reason that I did that was that it would slow them down just so that they don't overthink it, and then that way they absolutely know what they're doing. For example, if I wanted to write an equation of line that is parallel, or excuse me, perpendicular, I'll just take one real quick here. If I want to write an equation that's perpendicular to this one, through that point, what I would do always is, first of all, identify my original slope. In this problem here, what's the original slope? -2, good. What's perpendicular to a -2? Very good, 1/2. Change the sign, flip the fraction. So opposite of a negative is positive. The reciprocal of 2 is 1/2. And then I would use point slope form. Do you guys remember what point slope form looked like? Okay. Point slope form is one of the most useful forms of equations because all you need is a point and a slope. I have a point, I have a slope. I substitute in. Point slope looks like this. Y minus y sub 1 is your slope times x minus x sub 1. And then we just substitute in our values. Okay. Once we substitute in our values, we would just then solve that equation for y to get it into slope-intercept form. mx plus b. And the real reason why we use slope-intercept form all the time is because there is a button on our calculator that says y equals. So we can graph things real quick, right? Anytime we can get y by itself, it makes our lives happy because we can always go to our calculator, look at the graph, go to the table function and actually go through values of it to see what specific functional values are and do all that kind of stuff, okay? So let's see, our point was what? Negative 4 and 6. So I'd go y minus 6 is 1/2 x plus 4. What's half of 4? What's 2 plus 6? 8. There's your equation. You're done. Okay. Remember, when you're writing out equations of lines, I wouldn't write it as x over 2, even though it is technically your right answer, because if you have a graphic, you're going to walk your slope up 1 over 2, up 1 over 2. That way you don't mess that up. Okay. Does that vaguely ring a bell? Ish. See what else was there in here. Writing equations of lines given 2 points. Remember how to do that? I'm guessing no. Yeah, write the equation.
Isn't that y2 minus y so 1 over x 2?
Yeah, you're saying. Yeah, you're on the right track. So if I want to write the equation, if I want to write the equation in the slope-intercept form, given a pair of points, what's the first thing you have to do? Find the slope. Okay? Find it. I know. I'm such a jerk. Did you forget how to find said slope?
It's right there.
Every once in a while I have an idea of why I leave stuff on boards and things. Alright, so find your slope, -2 minus 0, -1 minus 3. So you have 1/2 for the slope. And then when you go to write the equation, does it matter which ordered pair you choose? Which one do you think will be easier? The one with the 3 and the 0. Yes, ma'am. It's y2 minus y1, so it'll be -2 minus 0. You flipped it? Welcome back. So then just go through it, and we have y, well, minus 0, which doesn't do anything for us, is half of x minus 3. So it's y equals 1/2 x minus 3/2. And I'm done, and I go to the next problem. Okay? A lot of times when we do graphs You may wind up with fractional intercepts and stuff like that. I try to make sure that if you have to do that by hand, it's not anything crazy. Because if it's a halvesy, we can kind of figure it out. It's not that bad. Even if it's a third, I mean, you just put in a dot somewhere and you kind of get the idea of it. But I'm trying to make it too great. It did. Very scary. Very frightening. How much further I want to get to today? I don't want to go much further. Okay, I'm done.
Is there a fraction bar?
What's that? Alpha y equals. Great question. To create a fraction on these things, guys, if you're going to figure out your slopes, because it will simplify everything for you. If you do alpha y equals, enter, and there's your fraction bar. And hey, you can put that equation right in. You could have typed -2 minus 0 over 1 minus -3, and it'll spit out a simplified fraction for you. It'll do it right away. Okay. So yeah, just like you guys had the multi-view calculators last year, if you go this route with this, it's going to work just the same. Okay. I think I already put the assignment online. Why don't you guys just do the 2 through 20 on this for right now, on 127. Evens.
That's homework?
Yes, ma'am.
Oh, right. 20.
Evens on the 127, okay? We'll just set that up for today. We'll work on the rest of the equations and graphing tomorrow. Yeah. Just add to what you already have, guys. Add to that chapter 1 stuff, okay? And we'll collect it all at the same time. Yes, ma'am. What's that?
What's your revolution turning?
I'll tell you when it's due.
So,
Oh, I just passed. Yeah, I'll just pack up the paper and all that.
so for